Okay, let's start with something that seems pretty different. NASA rockets and oil and rigs. What do they possibly have in common? Turns out a lot. Both of involve super complex, high risk, crazy expensive technology. And in both cases, if the tech fails, the consequences are massive. For NASA, it could mean a failed space mission. And for oil and gas, it could mean losing billions, or worse, environmental disaster. So how you actually manage that risk? How do you know when a piece of technology is ready to move from a research lab to a real world, where it has survived seas, salty oceans, crushing pressures, and non-stop operations? That's where something called TRL, Technology Readiness Level, comes in. It's basically a ladder of confidence. It takes an idea from sketch of paper, step by step, all the way to a piece of engineering that's safe, reliable, and deployed in field. NASA first used it, well, simply because you can't test a rocket by trial and error in space. Oil and gas companies later adopt it for the same reason. Because building giant subsea pipelines, compressors, or gas to liquid plants is kind of like going to space. It's extreme engineering. And here's the cool part. I've actually been through this process myself, from the early research stage to development to deployment offshore. So in this series, I'll walk you through what TRL looks like in action, using the examples of building offshore pipeline technology. So let's climb this ladder together. We'll start at the very bottom. TRL1, that's where everything begins, with just an idea. And trust me, this is where things get exciting and messy. So TRL1 is where all it begins. Raw research. Think scribbling on a napkin, equations on the whiteboard, or lab experiments that barely hold together with the duct tape. For offshore pipelines, this might look like, what if we use a new composite material instead of steel, so they don't corrode in seawater? At this stage, no prototype, no hardware, just science. Then only comes TRL2, concept formulation. And you ask, okay, how would this actually work? Could this new pipeline material handle high pressure? Could it bend with ocean current? And at this stage, I've sat in rooms where we brainstorm wild ideas. 90% go to nowhere. But that 10%, that's where the magic happens. These are the early steps that don't look impressive from the outside. Just experiments in lab, sometimes failing more than succeeding. But even rockets, every subsea pipelines and every new energy tech started with this kind of rough idea. Without TRL 1 and 2, nothing else climbs the ladder. And honestly, this is where engineers need to most have imagination. Because at this stage, you're basically betting that your crazy sketch might one day turn into $1 billion infrastructure. Next up, TRL3. And that's when we finally stop dreaming and start building something that we can actually touch. And TRL3 is where things get real. Now you've moved from equations to an actual lab prototype. It's clunky, it's ugly, And it probably doesn't survive outside the lab. But it proves one thing, that the science can work. For offshore pipelines, this might mean making a small section of composite pipes and testing it under controlled condition. High pressure chambers, salt spray, temperature cycles, to name a few. When this passed, only then TRL4 came. Validation in a lab. This is where I spent hours with engineers running the same test hundreds of times, trying to break the prototype on purpose. Because if you can't break it in the lab, you have no chance in the ocean. And at this point, there are still tons of doubts. Will it scale? Will it connect properly to an existing steel system? Will the regulators accept it? But the difference is, now that you have a real object to point, you no longer say, what if? You start looking this thing that would really exist. And that is a massive psychological shift. TRL3 to 4 is where dreamers turn into doers. Next stop, TRL5 and 6. And that's when we leave the safety of the lab and test it in the real world. All right, TRL5 and 6. This is where we get both thrilling and terrifying, because now we're testing outside the lab. For our pipeline example, imagine dropping a section of that pipe into a test site offshore. Not a full deployment, but enough to see how it handled the waves, the current, and actual seawater. I still remember when we did this. Everyone held their breath, which spent years in lab. But this was the first time that the material meets the ocean. Would it leak? Would it snap? Would it dissolve? TRL5 is the control fields testing. TRL6 is the prototype demonstration in a relevant environment, meaning you are really testing it in the condition that looks like and feel like the real thing. And in TRL6, you've built a near final version. For pipelines, this could be a full segment installed along a real system, running actual fluids. It means it has been proven to operate in a real environment. And by this point, you've probably solved countless of problems nobody thought of earlier. Like, how do you repair it? How do you connect it to existing systems? How do you think it would behave after months of constant flow? I've been in projects where we were so close, but we still have to go to the drawing board. But here's the thing, TRL is not just a straight up ladder. Sometimes you climb, then you slip back a step. But by the time you reach the final TRL, TRL7, the world starts taking notice. Partners, investors, regulators, they see your tech for real. And in TRL7, your technology is not only deployed at full scale, but it's really doing its job. In our example of a pipeline example, that means kilometers of new materials has been installed in offshore, moving thousands of barrels of oil and gas every day. And let me tell you, standing on the offshore platform, watching something you helped push through the TRL process actually working is an indescribable feeling. Years of research, testing, failures, redesign, all accumulating into something that now looks ordinary, but is extraordinary in what it took to get there. And this is where you'll see why TRL matters. It's not bureaucracy. It's not red tape. It's a reason you can trust these systems won't fail when lives, money, and environment are on the line. But it is not at the end of the story for TRL-7, because each new deployment teaches us lessons, which means we can look back, look at the cycle, and continue the innovation. So why should you care about TRL if you're not an engineer or working offshore? Because the same process applies to every advanced technology around you, from the phone in your hand to the batteries in the electric cars, to the rocket that land themselves, and every one of those that went through the same version of TRL. It's about trust. Would you fly a plane built on a sketchy prototype? Would you power your home with an untestable tech? Probably not. TRL gives us a language to say, yes, this is ready. It's not perfect, but it's proven. And having been part of this process myself, I can tell you it changes the way you see technology. You stop asking, is this cool? And start asking, is this ready? That's the difference between science fiction and engineering reality. Looking back on my own journey across research, development, and deployment, the biggest lesson is this: innovation, it's never linear. TRL looks like a straight ladder, but in reality, it's more like a game of snakes and ladders. You climb, you slip, you climb again. The other lesson: collaboration. No single engineer takes a technology from TRL-1 to TRL-7. It takes researchers, designers, regulators, funders, operators, all working together. I've seen ideas fail not because the tech was bad, but because the ecosystems around it was not ready. And that's humbling, because it shows us innovation isn't just about science or engineering, it's about timing, trust, and teamwork. So here's the big question: where does TRL take us next? In oil and gas, it's not just pipelines. It's digital twins, carbon capture, hydrogen transport, AI-driven maintenance, all climbing the same ladder of readiness. Some are at TRL2, some are at TRL6, and if history tells us anything, the world will only trust them only once they have proven themselves step by step. For me, having been through this journey, the TRL process is not just a framework, it's a mindset. It reminds us that bold ideas can become reality, but only if we respect the processes, test ruthlessly, and learn every step. And that's why, whether it's rockets to Mars or energy deep beneath the ocean, TRL will keep guiding us. So the next time you hear about a breakthrough energy technology, ask yourself, what TRL is this? Because that single question tells you how close are we to the future.